Okay, so we are the Red Dwarf Group. We've been around for a while, as you'll hear. As I was kind of thinking about this meeting, I just put together a sort of brief over, like the 10 seconds soundbite, right, to what
Hmm.
we do. So I came up with extending our knowledge of flare stars through amateur and professional collaboration. I think that's kind of what we're trying to do as an overall project, right? There's a lot of flare star work going on out there. We've got some very keen amateur observers that have come together under the auspices of the Red Dwarf Group, and that's kind of it. And I think one of the things that makes us unique is that we can observe what others cannot. And I don't mean this in the sense of we've got big telescopes and therefore we can, see faint objects and stuff like that. I think it's more to do with the fact that some of us are prepared to dedicate hundreds of hours of telescope time to this one project.
Mm.
Um, in 2024, and I only started mid-year, I've already logged over 500 hours of observation on a single star. And so some of us are prepared to do that for the overall goal of the project. So the two people on the call today are myself. I'm the coordinator of campaign number two. I actually do come from a research background. I did my initial research in satellite communications back in the day, which then led to a long corporate career working for companies like Orange, which you probably
Yeah.
know through France Telecom, right? I was actually the 69th employee into Orange when that company was first formed. Um, and then I retired a number of years ago. I'm now a mentor for the AAVSO. I kind of similar to some of your goals, right? I try and bring astronomy to those or science to those folks that have not been doing it. So I like to try and specialize in bringing astrophotographers into the world of science. And I'm also a member of the San Diego Astronomy Association. Bob, who is joining us, and hopefully, Bob, I've got these facts correct. Bob was the organizer for campaign number one, which was pretty successful. And Bob did a great job of laying a lot of the foundations that I'm actually able to use for campaign number two. Bob also comes from a technical background. He has authored a couple of books, one of which was my inspiration to get into the science side of astronomy, The Sky is Your Laboratory. And Bob is the president of the Society for Astronomical Sciences. He's an ex-board member of the AAVSO, and apparently I forgot to type AAVSO in the presentation there. And he's also the author of multiple publications. Bob, is there anything you want to add to that? Since um,
That's more than enough.
that's more than enough. Okay, great. All right. So, a brief history of the Red Dwarf Group. The Red Dwarf Group was formed in 2001. It basically runs as an invite-only group. We have you can apply for membership. I mean, there's no particular um, difficult criteria to meet. We just want to make sure that we get a group of people that are all kind of like-minded and kind of have the same goals. We run it through a Groups IO page, and then we also have bi-weekly meetings that John Bruno and others participate in, where we discuss the current status of the project and what we're working on and a whole boatload of logistical issues. Basically, as I kind of already said, we're a worldwide collaboration of experienced observers and scientists. We are focused on the amateur professional collaboration aspect, and we're currently developing that team for campaign number two. And we're dedicated to the study of flare stars, red dwarf stars, which is obviously where the group got its name from. We've
Hmm.
already achieved some pretty exciting results through the work that we've done. We've published multiple papers, which I'll give you a few links to. So if you want to go and take a look at those, that will give you a lot more information about the technical aspects of what we do. Campaign one, which was run by Bob, ran from approximately 2021 to 2023. There then was a little bit of a drop. Well, in fact, the group stopped for a period of time. We have a sister group called the Spectroscopy Discussion Group, and a lot of the members then started looking at other stars of different types. They did a lot of work, for instance, on HD 5501, which is a very complex triple star system with an accretion disk and so forth and so on. So a lot of our members went over to do other work, but I kind of resurrected things in September of this year. So we've kicked off again in 2024. And basically, my goal here is to run a 2 to 3 year campaign, which we sort of notionally call Campaign 2. This, I won't talk to this specifically, but here are some links to where some of our publications for campaign one thing, many of them appeared in the SAS conference proceedings of 2022. There are some links to a number of videos that were filmed at that conference proceedings regarding the papers. So if you're interested, please take a look through some of those. James Jackman, who is the last of those mentioned there, was our principal scientific advisor from the first campaign. And it looks as though we have engaged with James went out into the corporate world. We look like we've engaged with James's successor from Arizona State University. She is going to participate as well, and we're also looking for other professional collaboration for what we're trying to do. I actually, that we've had a number of other papers. I published a paper in 2023 through the Journal of the American Association of Variable Star Observers on EV-LAC. There was a particularly large flare that I was fortunate enough to capture in November, I believe, of 2023. And that paper covers that observation. Our goals for campaign number 2 are a 2 to 3 year follow-on campaign from campaign number 1. The original campaign was published, or at least was published, I guess is a word, in AAVSO Alert Notice 789, and we're hopeful that we're going to have another alert notice coming out, hopefully before Christmas, which will describe campaign 2 objectives. Campaign 1 was very much high cadence photometry and spectroscopy. Because of the way that the group is currently structured, we're more photometrically orientated than spectroscopically, but hopefully that will change with time. We've got a number of goals in terms of research. We are looking at flare frequency distributions, and one of the reasons we're doing this is because my observations have shown that EV-LAC is certainly less active in 2024 than it was in 2023. Whether that's statistically significant is a different question, but there's at least a 30 to 40% drop off in flare activity. And so that kind of sparked our interest in getting campaign number 2 up and running again. We're also, we have a unique challenge in so much as many of our members are using different equipment. Some of them use B or V Johnson and Cousins filters. We've got one telescope that uses Sloan. I actually shoot in tricolor imaging. So we need to bring all that together when we're producing flare frequency diagrams, for instance, because obviously we've got a diverse set of filter groups, and we need to try and bring all that information together. The other thing that Bob and I are both interested in is we're not particularly thrilled with the current temperature model that's being used in the scientific literature for describing a flare, which then has obviously impacts on it, the calculated energy for that flare. And so one of our goals is also to see if we can come up with perhaps a more robust temperature model and publish some stuff around that. And my goal, coming from a research background, is to have the group publish peer-reviewed, high-quality scientific papers. Kind of like in the back of my mind, I'd like to see us getting out at least 2 papers a year, so maybe 6 or so papers over the course of the project. Campaign number 2 started in September of this year. The Red Dwarf Group has about 44 members at the moment, of which about 20 are currently active on campaign 2. As I've mentioned, we are looking to bring on board both more amateur and professional astronomers. Our main targets at the moment are the very famous flare stars of EV-LAC and AD Leo. And of course, they're always a great place to start because they are so active. And we spend hundreds of hours looking at flat lines, waiting for flares to appear in that thing. So, you know, having more or targeting more active stars is good because it keeps people's interest. That being said, of course, there's also a lot of published material already on those particular stars. The group is predominantly focused on photometry at the moment. I'm hoping that will change. We're currently in the process of developing a tool called Photostats. This allows us to take information derived from the main database that we use for storing our results, which is the AAVSO International Database. We can pull information back from that, parse it into a standard format, and then Photostats takes that information and allows, with user interaction, for you to do flare analysis and archive those results in what we've kind of fondly called a flare library. And we're just at the final stages of getting that developed and ready for issue to our team. And once we've got that, we've got a lot of data from 2001 through 2024 that we want to start looking at for our first paper to see if we can investigate changes in the flare frequency diagram that are statistically significant. I kind of mentioned our target list, so this is kind of more informational rather than anything else. So our next steps in the project are the completion of the analysis tool Photostats. That's written in Python. It uses many of the standard Python libraries. I mentioned the paper. As the team develops over time, we will revise our target list. I'd like to see more than 2 targets on that list, but obviously it kind of depends on the number of people that are active and doing are capable of doing long time series measurements. If we don't have a lot of people, then clearly our target list is small. If we do have a lot of people, then we can expand our target list. And we're looking for members from around the globe in the Northern Hemisphere predominantly. We do have one actually extremely active observer. He has millions of submissions to the AAVSO database in the Southern Hemisphere. So we're hoping to get him to do some work on Southern Hemisphere flare stars.
So Red Dwarf, there's no link with the British TV show.
Well, I mean, apart from the fact that I watched that show as a you know a youngster,
Yeah.
which was extremely funny, right?
Yeah.
And I'm sure if my daughter watches that show, she's 9, she will definitely probably characterize me as one of the characters within the plot, right? Since
You know, Yannic, since you're set up for time series photometry and spectroscopy, this might be something that you want to see if some of your students are intrigued by, because your equipment would be perfect. The original Red Dwarf campaign started because of the question, can we observe stellar flares with amateur equipment? And if so, can we make useful measurements of them, photometrically, spectroscopically? And if that's true, can we replicate previous published results, flare frequency rates, flare energies, the spectral energy distribution in a flare? And might we be able to provide new and useful analysis in the stellar flare research area? And it turned out that the answer was yes to all of those. And indeed, the key feature that amateur observers bring is the ability to spend an enormous amount of telescope time looking for an event that happens rarely and randomly, so you can't schedule it. As Gary mentioned, you stare at a star like EVLAC all night, every night for a week, and you may see one or two pretty significant flares out of that. Professionals just can't get the telescope time to do a project like that.
Yeah.
Here's an example of what you see spectroscopically when a flare happens. This, by the way, comes from an ALPI spectrograph, so a little lower resolution than your LISA.
Yes.
Some of our people are using LISAs with very good effect. AD Leo is an M3 class star, and even this is zoomed in on the hydrogen gamma line, and even when there's nothing happening, there's a little bit of emission line in H gamma because of the magnetic activity of the star. And when a flare happens, that emission line jumps way up and then gradually falls back down, returning to quiescence. If you plot the equivalent width of that spectral line versus time for this event, the blue dots are H gamma, and you see how over time there's a sharp rise in the emission, and then this gradual decay, meridian flip, and then the decay continues. And the duration of this event is several hours long. This was a pretty healthy flare. This kind of time series spectroscopy turns out to show a lot about the stellar flare activity, that the different Balmer lines rise and fall in sync with each other, but by different amounts, different amount of energy being released in the different Balmer emission lines as the flare cools off. We've also had schedules where we could stare at a star at the same time the test satellite was staring at the star, and at the same time ground-based photometry staring at that star. So we could see what was happening in the spectral lines shown on top. Similar kind of curve. You know, there's a sharp rise and gradual decay in the Balmer emission lines in this star. And before this event, it looked like there was something had happened on the star that we did not see the complete event. The test spacecraft, because it stares continuously for a month, saw a bright flare followed by another bright flare. The second one you can see corresponds perfectly with the spectral emission features that we detected, and it's pretty clear that we were seeing the decay portion of that first one. And on this guy, fortuitously, we had Johnson B-band photometry from ground-based observations. And so you can see the B-band photometry lines right up with the test satellite photometry with the ground-based spectroscopy. And it's interesting to note the amplitude of that second flare is less than 1/10 of a magnitude in the TESS photometry, TESS being near infrared, versus over a full magnitude in Johnson B band. The flares are hot, and hence they emit more at the shorter wavelength regions. The spectrum, if you have simultaneous time series spectroscopy and photometry, it turns out and show you not just how the emission lines bounce up during a flare, but also show that a sort of a continuum level bounces up much more strongly at the blue end than it does in the red end. Again, reflecting that the flare is a hot emitting source on the star. And from that, you can actually make a pretty good estimate of the temperature in the flare itself and plot that out over time. Since you stare at the star for a long time, a month or so, you see a lot of flares, and you see the standard flare frequency distribution. There are many small flares, very few large flares. This is a plot of flare energy on the bottom, high energy to low energy, and the flare rate. 1 every 100 hours for the highly energetic flares, 1 every 10 hours for the lower energy flares, and a pretty good fit to a power law distribution, which is what you expect to see from the published literature. The curve bends over here in the very small flares because at some point they're too small to reliably detect. And so that is a recognition of our probability of detection, not something that's happening in the star. Gary mentioned publishable results. Not just in the publications aimed at amateur small telescope, but monthly notices of the RAS and Astrophysical Journal that our group has been published in. The stars that we have focused on have been AD Leo, EV Lac, CR Draconis, EQ Pig, and fewer observations of these others, but most of those, I think, fall within your 10 parsec sample. And so if this is an example of the sort of characterization of these stars that your sponsor is interested in, there is a link there between us. And just to brag, this is my observatory in my backyard in central Arizona in the U.S.
Very nice.